Hi guys! Today we will be talking about the derivative of polynomials. And I know that sounds very confusing in English, and it maybe is very confusing in English, but I'm going to try my best to explain it so everyone understands, even though it is another language. So, when you are deriving a polynomial or when you are deriving an equation, there are two basic rules that you should always know before you start to go into more difficult equations. So the first of those basic rules, I'm going to take the easier one, and that is f of x is equal to x to the power of n. And when that is the case, when you go to derive, so prime of x is equal to n times x n minus 1. So I know it sounds very confusing and it's a lot of letters, so I'm just going to take an example and I will explain as I go along. So first example, I can take f of x is equal to x to the power of 7. So in this case, 7 is going to be our n. So when we go to derive f prime of x, we're going to take 7 times x to the power of 7 minus 1. So when you go to simplify it, the final answer will be 7 times x to the power of 6. So in this case, 7 is our n, and you can see here how we got the 6. So it is really a lot simpler than it sounds, I think. And we also have another rule that is important when you're deriving, and that is when you have a constant with x. So f of x is equal to k, your constant, times x to n. And when you have a constant, it is pretty much the exact same thing. If you can see this here is the same as this. The only difference is that now you have this k. So f prime of x will turn into k times n to the power, f prime of x will turn into k times n times x to the power of n minus 1. Whew, that's a lot of letters. So I'll take an example with this problem as well. I'll come down here for this one. And let's say f of x is equal to 3x squared. So when you have 3x squared, 3, this here, that will be our constant. So f prime of x is equal to 3, which is our k, times 2, our n for this problem, right there, times x to the power of 2 minus 1. So finally, when everything simplifies out, you will get 6x to the power of 1. And that is pretty simple. I think it's definitely very straightforward. But there is one situation where I think it is definitely easy to get confused. And that is, I will come over here for this problem. That is when you have a number by itself, let's say 6, for example. When you go to derive, that number will always turn into 0. And looking at this paper, it is confusing. How do you get from a full number, from a 6, how does that just go to 0? So I will go down here to explain. Let's take this f of x equals 6, and what you really don't see is that 6 is the constant, or the k, in this situation, and there is an x and there is an n, but their x is to the power of 0. So when x is to the power of 0, you can try this on your calculator, you can Google it, it will always equal 1. So a lot of times it is just left out because it is easier that way. You don't always write 6 times 1, but it is still there even if you don't see it. So when you take it like this, when you go to derive, it will turn into 6 times 0, in this case 0 is our n, and you will multiply it times x, 0 minus 1, there we go. And this 0, it will just wipe the entire equation out. So f prime of x is equal to 0. And finally, before we end, I will take one harder example, and just to see if we have actually learned something today. And here we go. I will take 3x to the negative 2 minus 2x1 plus 6. So we will follow the rules of deriving, which I've just taught you, and you will take this n, negative 2 times 3x, negative 2 minus 1, minus 2x, 1 minus 1, plus 0. And if you see, this is exactly the case that I was just talking about. This 6 turns into that 0 because of everything I've shown you up here. So we will take it one step further, and we will end up with negative 6x to the negative 3 minus 2x to the power of 0 plus 0. And when we end up simplifying this all out, in the end, our final answer will be negative 6x to the negative 3 minus 2, because this x to the 0 is really just 1, just like it is up here. So here is your final answer. And I hope you have learned something teaching when I have taught you today about the derivative of polynomials. Thank you.
Oh my god, I have to go.